Okay, hello everyone. So this is again the AZ-103 training for Azure Platform and Infrastructure. That's the previous name. Now it's called the Azure Expert, Platform Expert. So we'll be entering our module 5 called the Intersite connectivity. So last module, module 4, we covered the Azure Network, virtual network, and this is the sort of an extension of that module. That's why the virtual networking, it's taking 35% of the AZ-103 exam. So my name is Robin, or my English name. So I'm a Microsoft certified trainer. So I have both experiencing for the on-prem and online infrastructures, and I have been given the opportunity to be a Teams, SharePoint, and Exchange subject matter expert in my work, and I'm currently the tech lead at the Microsoft.com. It's not Microsoft, it's Microsoft.com. So it's been a while since I posted last video because I was collecting my daughter from my wife's hometown. So this is a picture of her on the way back on the train reading the safety manual. So yeah, it's quite a fun. So she apparently reached the age where just tear up everything and open the drawer and try to find out what's it's interesting about life. Okay, anyway, let's get on to it. So this module we'll talk about virtual the VNet peering, VNet to VNet connections, and express route. So I know some of the topics here might sound really interesting to you for production environment, but again, for the certification purpose, we will not go that deep or do much demo, and especially for the VNet to VNet connections. As you guys may know, I introduced I'm located in China, so the VPN thing, it's impossible here. So I cannot fetch any VPN devices or software that easily. Anyway, so I have to, for the physical device, I may have to go to some kind of a black market to go that. No, it's just kidding. So if you're a company, it's enterprise or working purpose, they let you use, but for personal use, you cannot get any of that events easily. And for express route, it's only on the theoretical level. We won't be doing any demo on that. I'm sure you understand, since it's not meant. It's only a demo environment, it's not a production. So it's really no purpose for me to doing that anyway. Plus, it's not be many questions or even 2 questions for this on the exam. But we will be doing a demo on VNet pairing. That I can guarantee. So let's start with the VNet pairing. We're dividing to this to 5. The pairing, configure the pairing, the gateway transit, global VNet pairing, and the servicing chain. So the global VNet pairing is very similar to the VNet pairing. So you can treat the VNet pairing here as the regional VNet pairing. So the simplest and quickest way to connect your VNet is use the thing we just introduced, VNet pairing. So this I mean the virtual network in Azure. Right, it's not from your cloud to your on-prem. The virtual network peering enables you to, in a way, seamlessly connect two Azure virtual network together. So once they're paired, the virtual network appears as one network. So for connectivity purpose, there are 2 types of VNet peering: the regional VNet peering, which connects the Azure virtual networks in the same region. That's the West US, East US, West US 2, East Australia, etc., etc. And the second one is the global VNet peering, connects your virtual network in different regions. So when you're creating global peering, the paired virtual networks can exist in any the Azure public cloud region or China cloud region, but not in the government one. So the China one referred to the operate 121 VNet, but the government one are isolated virtual networks. So you can only pair virtual networks in the same region in the Azure government cloud region. So if you have the US government one, they can only connect with each other within that subscription or region, sorry. And the benefits for using the local or global virtual, regional or global virtual network peering has, many benefits like its privacy. So the network traffic between paired virtual network is private, and traffic between the virtual network is kept on the Microsoft backbone network. So no public internet gateway or encryption is required in this communication between the virtual networks. The second benefit is its performance. It's a low latency, high bandwidth connection between your resources in different virtual networks. And communication, so the ability for resources in one virtual network to communicate with a resource in a different virtual network. So once the virtual network is, appeared, and there's no disruption, so no downtime to resources in either virtual network when creating the peering or after the peering is created. So there's no downtime like the full domain or update domain we talk about. So the virtual network will stay up all the time. All right. So to configure the VNet peering, right? So there are some steps you have to do to configure this. So notice you will need two virtual networks. You can not have only one, right? There's no peer if you only have one. So you need to have at least two. And if you want to do this, either it's make sure they're in the different region or same region as well. But there's just for all my demo, I'm going to put it in a different region. To test the pairing, you need to virtual machine in each network. So initially, the VMs will not be able to communicate, as in ping each other. But after the configuration, the communication will work. So the step is new. It's configure the peering of the virtual networks. The first one is create two virtual networks that we talk about. The second one is pair the networks, and we deploy virtual machine in each virtual networks. Then you test the communication between the the virtual machines. Right. So configure peering is very easy, right? Just to go to the sorry, let me just show you the demo real quick. So I have two machines actually already deployed because it takes several minutes to deploy the virtual machine and everything, so I deploy them beforehand. But let's get to the virtual network in place. So you click any of the your virtual network. So this is my demo one, so I'm going to use this to demo later, but let's click into the other one. So if you click into peering, right, you can see there's a peering, and this one is empty. You can add a peering. So name of the peering, so you can have any names, right? This is demo 02, and we choose the virtual network. You can see there's all the other networks will be listed here, right? So for this is my own one, right? I cannot peer with myself, but the other virtual network, West US, East US, or Japan East, the one you saw earlier, I'm able to peer with them. And I have to give the name for that as well, right? So uh, that's the basic step. So let me get to the PowerPoint. And there's options which you saw, right? Allow forward traffic, allow gateway transit, and use remote gateways, right? So the allow forward traffic is allow the traffic not originating from within the peer network into your virtual network, right? So that's the first one. And the allow gateway transit is to allow the peer virtual network to use your virtual network gateway. So the peer cannot already have a gateway configured. So that's something you have to remember. And the third, use a remote gateway, is use your peer's virtual gateway. So only one virtual network can have this enabled, not two. And remember, the peering must be configured from both ends. So if you have this two, so you have to do the same step twice in the two different virtual network, right? So once you configured one side of the virtual network, it will say it's initiated. After you connect the second one, it will say it's connected. Right, that's the step you have to do here. So yeah, so the screenshot is a little old. You can see here. So the configure forward traffic actually is different than the one we saw. There's no longer a checkbox. It's something called disable and enable, right? So yeah, so we just put this one here. Okay. I think I forgot something on this slide. Yes, remember if the virtual network, their space address can never be overlapped. So if they're overlapped, you will get a warning that this will not be successfully deployed when you click Save button. So we can try to do something here. Let's create a brand new one, shall we? Okay, let's discard the changes. So we add a new one. Okay. To take a little long, so okay, no problem. So let's call this Intersite. No, I think Intersite is taken, so we'll call this AZ-103 uh, VNet demo 1. All right. Let me copy the name so I can use the change the number. So notice this address space 10.3.0.0/16, right? Resource group, let's select the Intersite demo as well. So location, let's use this as the South Central US. So we will create the other one in the North Central US. Name, let's call it default one. All right, so everyone is one here. The subnet is this. All right. We leave the other at default and we hit create. Okay, let's quickly, huh? I thought it's been created or not. Let me refresh. Okay, it's there anyway. So the warning is pointless. Let's name the second one 2. And notice 10.4.0.0, right? If we change this to 3, actually, let's not change this one, right? Just leave it. I don't want to repeat the steps. So this 2, and then we create. Now we can create another one just for demonstration purpose. Let's call it a 3. Oops, 3. And we change this to 4. Let's leave it at 4, right? Just for demonstration purpose. And let's create this one. Yeah, Central US 3. All right. Oops, my bad. Okay. Okay, so it should be fairly quickly finished. Okay, the last one seems to take a little bit of time, so let's let it run. So we click into any of the virtual network we have, and we go to the peering. So I always have trouble memorizing where each one is, so I just search the name, right? You can notice this is empty here, so we click add. So right, so we click give it a name demo 111, right? So that's pairing with this is in the South US, right? Let's create the one in the North US, North. Uh, where is that one? Oh, okay, North here. Okay, name of the pairing from, this is new pairing. All right. We click OK. What's this doing here? Let's click refresh. Ah, it's connected. So let's close this one and we go to the demo 2. All right, so we click add. South. Okay. The readiness. Okay, because it's paired, that's why you get this warning, right? So let's add this with another one. So the one we have is South Central US, right? Pairing 3. Yes, also a warning, right? Okay, so here it goes. That's a little bit different than actually the PowerPoint slide. I think uh, the the second one. So the original, I think just for yesterday or not yesterday, a week ago when I tested, it's a little bit different. So the pairing you have to configure from both sides. So actually, if you just go to the next one, you can see, right? It will say as it's initiated, right? So you have to configure from both sides. Apparently, Azure has changed now for this one. So when it says it's initiated, so when you create the pairing to the second virtual network from the first virtual network, they will be saying as initiated. And when you create the pairing from the second virtual network to the first network, the pairing status is connected. So whenever it's connected, you can do the ping from two virtual machines. So yeah, this is again probably my bad, but again, this is cloud technologies keep updating all the time. You can never foresee when it's coming. So yeah, so now apparently you don't have to connect from both ends. So from one end, it's will suffice. All right. So anyway, uh, let's do test the connection. So we'll not be testing the connection from this one we just connected because I have to deploy virtual machine inside. Let's use the virtual machine already has. So you can see I have these two, right? Machine 3 and machine 4. One's in East US and one is in West US. And they belong to different virtual networks as well. One is the peering demo 1. So this will have the machine 3 and another one has the machine 4. So apparently I have two other another machine here as well, but I didn't turn that on. So we just do one I have. If you do not trust me for the demo, we just click into diagram so you can see what's inside. Again, this might be a little bit slow, so just to prove that it's an actual thing that's been happening. But yeah, again, this might take some time to load. So I will just download connect my virtual machine first. All right. So oh come on, connect, and I'm already on machine 3. Okay, the previous name. Now let's click into the diagram of that one. Let me drag this one here, actually, and we connect the machine 4 as well. Oops. Okay. So you can see machine 3 is deployed here. Machine 4 is not within the same virtual network and different region or anything. There's no tricks. So we go to machine 3 and we copy the IP address of machine 4. So we go to the machine 4 and that's the private IP address. So now we open machine 3. And remember, for this to work, you have to first allow the ICMP traffic through your firewall first. Otherwise, your ping will not be successful. All right, so now we ping. Make sure I've just did I copy the correct one? Yes. Okay. This is a little bit slow, but here, but you can see there's one package loss, so it shouldn't like this. So now I have 4. Yeah, correct. And we do the same for machine 4. So we go to click machine 3, copy the private IP address. We do here. All right, here you go. That's how the pairing works for to connect your network together so they appear as one. Okay, now so you can notice here I didn't configure any DNS settings, and there's no way I can configure the DNS settings for these two machines because they're different region. They're not within the same region or same same virtual network. So uh, for them to ping each other, you have to connect the pairing, right? So this is not like deploy your Active Directory in the cloud and your join domain from there, where you have to specify the DNS server for that one. So this is completely different uh, logic and technology, right? So let me close this too. All right. So for people who want to see demos, that's the only demo you're gonna get for this module. The other, as I explained, I'm unable to demo that, so I will just go through the PowerPoint on each one, right? So let me close this and I turn off this for. Don't waste any of my money here, all right? Okay, let's go back to it. So yeah, we talk about this one, and remember this has been updated, right? So this slide is a little bit old. I just want to emphasize in case you are doing the practice yourself. Okay, and the servicing chain, right? So the virtual pairing is a non-transitive. So this means that if you establish your virtual network pairing between VNet 1 and VNet 2 and between VNet 2 and VNet 3, the VNet pairing capabilities do not apply between VNet 1 and VNet 3. However, you can leverage user-defined routes and service chain to implement custom routing that will provide this transitivity. So this allows you to implement a multi-level hub and spoke architecture and overcome the limit on the number of virtual pairings per virtual network. So you can deploy the hub and spoke networks where the hub and virtual network can host infrastructures, components, such as network virtual appliance or VPN gateway. And all the spoke virtual networks can then pair with the hub virtual network. Traffic can flow through the network appliance or VPN gateways in the hub virtual network. So the user-defined routes and the servicing chain as the virtual network pairing enables the next hop in the user-defined routes to the IP address of the virtual machine in the paired virtual network or VPN gateway. All right, so the servicing chain enables you to direct traffic from one virtual network to a virtual appliance or virtual network gateway in a paired virtual network through the user-defined routes. So this might be a little bit confusing, but anyway, just for you to know, you can say this now if you connect VNet 1 to VNet 2, pair those 1 to 2 and pair 2 to 3, but you cannot ping VNet 3 from VNet 1. So you need to use the servicing chain for that to work. So, okay, let's go to our lesson 2, VNet to VNet connections. Right, this is the sort of like a big one. So we're gonna cover all this points in this lesson. Right, so you can connect your VNets with the VNet to VNet VPN connection. Using this connection method, you create a VPN gateway in each virtual network. A secure tunnel using the IPsec, if you're familiar with IPsec, provides the communication between your networks. So with the VNet to VNet connection, your VNet can be in the same or different region, like the pairing region. It's in the same region or different region, and in the same or different subscription, or in the same or different deployment methods, modules, or in Azure all on premises. Right? Because you have a VPN there, right? That explains. And the benefits for doing this has, first is cross-region geo-redundancy and geo-presence. You can set up your own geo-replication or synchronization with secure connectivity without going over the internet-facing endpoints. Of course, there's other way to do that, but if you prefer to set up your own geo replication, using a secure connectivity, you can do this. So with the Azure Traffic Manager and Load Balancer, you can set up the high availability workload with a geo redundancy across multiple Azure regions as well. And the second benefit is the regional multi-tier applications with isolation or administrative boundaries. So within the same region, you can set up multi-tier application with multiple virtual networks connected together due to the isolation or administrative requirements. And VNet-to-VNet communication can be combined with the multi-site configuration. So this lets you establish your virtual network topology that combines the cross-premises connectivity with the inter-virtual network connectivity. And here are the steps to implement the VNet-to-VNet connections. So first 4 steps you have to do in Azure. The second part is you do in on-premises. Then you test or verify and create the connection in Azure again. Right, but as I said before, I'm unable to demonstrate this. So if you want to see the demo, you can skip. But if you want to understand the logic, the reason, the definition, everything, what's in each step, you can stick to this PowerPoint. So first step is to create the virtual networks and subnets. It's very easy, right? So by now you should be familiar with creating virtual networks and subnets. And remember, for this VNets to connect to an on-premises location, you need to coordinate with your on-premises network administrator to reserve an IP range that you can use specifically for the virtual networks. You do not want any overlaps. And optionally, you can specify the DNS server. So the DNS is not required for create a site-to-site connection. Site-to-site is the term in VPN connection. So there have a point-to-site and we have a site-to-site. Just for folks who are not familiar. So however, if you want to have the name resolution for resources that are deployed to your virtual network, you should specify a DNS server in the virtual network configuration. So take some time to plan your network carefully. And if a duplicate IP address range exists on both sides of the VPN connection, traffic will not route the way you may expect it to. Right. So this is very important. I think we have mentioned the IP address overlapping more than 20 times already in the last previous and this module combined. Right. So here how you create the gateway subnet. So before creating a virtual network gateway for your virtual network, you first need to create the gateway subnet. So the gateway subnet contains the IP address that will be used by the virtual network gateway. If possible, the best create gateway subnet by using the /28 or /27 to provide enough IP address to accommodate. So accommodate any further additional configuration requirements, you want the largest you have. And when you create your gateway subnet, the gateway VMs are deployed to the gateway subnet and configured with the required VPN gateway settings. You must never deploy other resources, for example, additional VMs, to the gateway subnet. The gateway subnet must be named gateway subnet, right? So there's a lot of something you have to remember. And when working with gateway subnet, avoid associating a network security group, NSG, to the gateway subnet. Associating an NSG to the subnet may cause your VPN gateway to stop functioning as expected. If you remember, the NSG works as like a firewall, right? So there's some default rules there you cannot change, and if you already have an NSG and you associate with it, then by default the inbound outbound rules you have may interfere your connection. So that's something you have to remember. But if you want to use the NSG, just make sure all the ports are necessarily blocked or opened. And you have to create the second step, create the VPN gateway, right? So the gateway type and the VPN types are covered in the next 2 topics, so we will not be covered here. So the VPN gateway is a specific type of virtual network gateway that is used to send encryption traffic between your Azure virtual network and on-premises location over the public internet. So you can use the VPN gateway to send encrypted traffic between Azure virtual networks over the Microsoft network. So remember I said the Azure virtual network over the Microsoft network. So there are two different terms here. Right? But we will separate those terms of their definitions and everything in later modules. And each virtual network here can have only one VPN gateway. So, however, you can create multiple connections to the same VPN gateway. When you create multiple connections to the same VPN gateway, all VPN terminals share the available gateway bandwidth. And here, all the options you have is the name of the gateway types, VPN type. So most VPN types are route-based. SKU, use the drop-down list to select a gateway SKU. So your choice will affect the number of tunnels you can have and the aggregate throughput of the benchmark. The benchmark is based on the measurement of multiple tunnels aggregated through the single gateway. It is not a guaranteed throughput due to the internet traffic, different conditions happening, and your application behavior as well. And virtual network, associate a virtual network with the gateway. Before you do this, you must configure the gateway subnet, and each virtual network will need its own VPN gateway. And of course, public IP address as well. So this one can take up to 45 minutes to provision. Right, so this you have to remember. It takes up to 45 minutes. This is correct until today. So that can guarantee you. It has been reduced anyway, so it will take this long, almost an hour. So after the gateway is connected, created, view the IP address that has been assigned to it by looking at the virtual network in the portal. The gateway should appear as the connect device. So in the last step, we will create a connection for the device, which is 5 steps from now. And VPN types. So when you create a virtual network gateway for your VPN gateway configuration, you must choose a VPN type. So the VPN type that you choose depends on the connection topology you want to create. For example, a point-to-site connection requires a route-based VPN type. A VPN type can also depend on the hardware that you are using, right? And the site-to-site configuration requires a VPN device. Some VPN devices only support a certain VPN type. So the VPN type you select must satisfy all the connection requirements for the solution you want to create. For example, if you want to create a site-to-site VPN gateway connection and the P2S, so point-to-site VPN gateway connection for same virtual network, you would use a VPN type route-based because point-to-site requires a route-based VPN type. You would also need to verify that your VPN device support the route-based connection. So what's the point-to-site? The point-to-site it's things like you're working from home and you need to access resource like file share from your internal network, and then you use the VPN for like one-time access, right? But the site-to-site is always connected. So that's the general explanation I use to my other students and colleagues. So we introduced the VPN types, right? So the first one is policy-based types. The policy-based VPN encrypt and direct packets through the IPsec tunnels based on the IPsec policy configured with the combination of address prefix between your on-premises network and Azure VNet. The policy or the traffic selector, whatever you prefer, is usually defined as an access list in the VPN device configuration. So when using a policy-based VPN, keep in mind the following limitations. First, policy-based VPN can only be used on a basic gateway SKU, and it is not compatible with other gateway SKUs. We will introduce the SKUs in the next slide. So second, you have to have only one terminal with using a policy-based VPN. Third, you can only use policy-based VPN for site-to-site connection and for certain configurations. So most VPN gateway configuration require route-based VPN, like the point-to-site we said, right? And the second is route-based VPN. The route-based VPN use the routing the IP forwarding or route table to direct packets into their corresponding internal interface. The internal interface then encrypt or decrypt the package and in and out of the tunnels. The policy or traffic selector for route-based VPNs are configured as any to any, so it's a wildcards. So once a virtual network gateway has been created, you can change the VPN type. Remember, you cannot change the VPN type. So here are the SKU we talk about. So when you create a virtual network gateway, you need to specify the SKU so that you want to use, select the SKU that satisfy your requirements based on the type of workloads, its throughput, features, and SLA, of course. So aggregate throughput benchmark is based on the measurements of multiple tunnel aggregate through a single gateway. The aggregate throughput benchmark for a VPN gateway is site-to-site plus point-to-site combined. Remember, it's site-to-site and point-to-site combined. The aggregate throughput benchmark is not guaranteed for its throughput due to the, as we said, the internet traffic condition and your own application behaviors. So this connection limits are separate. For example, you can have the 128 SSTP connection and also a 250 IKE v2 so connection on VPN GW1 SKU. And remember, the basic SKU is considered a late legacy SKU. The basic SKU has certain feature limitations. You can resize the gateway that use the basic SKU to one of the new gateway SKU. You must instead change to a new SKU, which involves deleting and recreating your VPN gateway again. So remember, just do not use the basic one, right? It's a legacy one. Choose any other one, VPN gateway 1, 2, or 3, if possible. And next, you need to create the local network gateway, right? So the local network gateway typically refers to the on-premises location. You give the site a name by which Azure can refer to, then specify the IP address for the on-premise VPN device for the connection. You also need to specify the IP address prefix that will be routed through the VPN gateway to the VPN device. The address prefix you specify are the prefix located on the on-premise network. The IP address means the public IP address of the local gateway, not the internal, no, sorry, the private one, private IP address. And next, you need to configure the on-premise VPN device. So there's a list of supported VPN device provided by Microsoft. So you can, it's in the video description below. You can browse into that. So I have all the links you can use and leverage for learning this lesson, right? So depending on the VPN device that you have, you may be able to download the VPN device configuration script as well. So there is a script you can run to configure those devices. So to configure your VPN device, you will need a shared key. So this is the same shared key that you will specify when creating the VPN connection. And you need the public IP address, of course, of the VPN gateway. When you create a VPN gateway, you have configured the new public address or use the existing IP address, same as the way you're doing for the virtual machine. And next, you will create the VPN connection. So once your VPN gateway are created, you can create the connection between them. So if your VNets are in the same subscription, you can use the port. You can use the portal to configure. So names, just enter a name. Connection types like the VNet-to-VNet from the drop-down list. And the first virtual network gateway, this field value is automatically filled because you are creating this connection from specified virtual network. And the second virtual network gateway, this field is the virtual network gateway of the VNet that you want to create a connection to. And shared key, so enter the shared key for connection. Right, so the concept is similar here, except that rather than connecting to a VPN device, you are connecting to another virtual network gateway. Right, so if your virtual network gateway, if your virtual nets are in different subscription, you must use a PowerShell to make this connection. So you can use I think the command is, let me just type here. Okay, it's a different screen. It's new AZ virtual network gateways. So I remember this because it's very easy to remember for this command, right? So it's easy virtual network gateway connection, right? So this command can also be used for set-to-set connection as well. And the last step is to verify the VPN connection, right? So once it's connected, you are able to see it says it's connected, not connected, and you will see the data flowing in and out from here, data in and data out. No, cannot be 0 bytes. It's not possible, and you can verify using PowerShell as well. And yeah, so we won't be able to do any demo for this one. So it's very theoretical and some DAO listening for you to study. But again, as I said, it's not taking a lot of place in the exam. However, it does take a lot of space in your production practice. So yeah, so we're already up to our time for 40 minutes. I don't have time to go through the express route. So the next lesson, we'll just focusing on the express route. Probably just spend like 15 minutes talk about the express route and some basic Azure networking, right?